question 4. We have find integral of these two functions. There's need for us to use what? A trig identity. And we're going to start from here. Solution. Note that 1 plus tan squared theta is equal to what? Sec squared theta. And we can make tan squared theta as a subject. Tan squared theta is equal to sec squared theta minus 1. And the reason for doing this, the bone of contention, is that there's no direct table. There's no integration table for tan squared theta. We can now go back to our question. We now have theta times this one. Anywhere you see tan squared theta, we plug in this value. So we have this. So you can open this bracket, integral of this, theta, minus what? Integral of theta. So that's what we have now. This one, we're going to solve this one. This one has a direct answer. Integral of this one will be equal to what? If you integrate this one, respect to theta, this is having power 1, so that will be theta to power 2 over 2. So this one is done. But this one is a product of two items, and that calls for what? Integration by parts. So what we're going to do now, we're going to look for the one that is differentiable. So that will be u because of what? Theta. And then the u respect to theta will be what? With theta. Then the v is equal to what? Sec squared theta, the theta. Okay? So this is your the v. So integrate this one, integrate this one. So if you do that, this is what? V equal to tan theta. Then we can apply the formula for integration by parts, which is what? Which is uv minus integral of v du. We have our value for u, which is theta. We have our value for v, which is tan theta, minus here, this will be what? Theta. The u is equal to what? Is equal to the theta. Okay, so we now have this minus, we can break this one down. That's a sine over what? Over cos theta. That's for tan theta. So what I'm going to do now, I can also use, again here, U-substitutions, okay? But I want to do it straight away. The derivative of cos, derivative of cosine is minus sine theta, which is almost the same with what? With the numerator. So I'm going to introduce minus here. I'm going to cancel it outside, okay? So times minus again outside. So that will be what? That will be plus there, okay? So this one becomes plus, okay? So I will now have plus. Whenever your derivative of the denominator is equal to numerator, it's equal to the ln of the denominator. The final conclusion, this question will now be equal to what? We have this, and then minus what? Minus theta squared over 2 plus c. Another way, when you are here, or let me say when we are here, we can express our answer in another form, which is this. I can take this one outside, sin theta over cos theta, and solve it out separately. So if I do that, it's going to be minus sin theta, as I said, okay, over what? Over cos theta. And the minus that I introduce here, go to what? Cancel that outside, okay? And that will be equal to what? Minus ln what? ln cos theta. And if I return this minus back, according to the laws of logarithm, so this will be ln of what? Cos theta to power minus 1. That will be equal to what? ln sec theta. This one is 1 over cos, which is what? Sec theta. So instead of having plus here, our answer will now become minus ln sec theta, okay? And then minus what? Minus theta squared over 2 plus c. So the two answers are correct. You can leave your answer in this form. You can leave your answer in this form. Those two answers are perfect. They are correct. So that's that on this question. Yeah, for this question, find integral of this. What we're going to do here, the strategy will be a little algebra and then use substitution. Okay, that's the solution to that. We're going to break this one into two parts, and one part will be what? X to the power 3. So it will be this, and then times what? Times this. Okay, that's the first thing we're going to do. Then the next thing to do now, we're going to use the U-substitution. Let u be equal to what? Be equal to this. So what we're trying to achieve is that the moment we go for we do the U-substitutions on these two now, this one we cancel. So let's see how it goes. So the u now will be equal to what? 3s squared, the what? Dx. We can make these two items the subjects. So we have the u over 3 equal to what? So that's what we have now. Then we can go back to this place. So this will be integral of what? Okay, so you can see this one, these two, they are together. So then let's now change the variable now. So that will now become u here, and then e exponential to power what? Minus u. Then these two items, s squared dx is equal to what? That's du over 3. So this is what we have now. Yeah, let's put it on the outside, then we have this. Then this call for integration by parts. Yeah, these are two products. The divisible function I'm going to use W is equal to what? Is equal to U. So the W is equal to what? The U. Then the V is equal to what? Is equal to this. If you integrate this, we're going to have V equal to this one, okay, over what? Over minus. And that will become this one to be what? To be minus here. When you integrate exponential function, it's going to give you back that function. But you have to check this place. What is the derivative? And use it to divide the what? The function. So our formula will now become what? Instead of saying UV now, I'm going to say WV minus integral of what? V dW. Because it will be a tautology to use U for U here. That's why I changed the variable to the W. Now begin to substitute. We have our U, our W as this, and we have our V, and that will be equal to minus U exponential to our minus U minus integral of my V is what? My V is this. This minus can go outside. That becomes plus. Then this function times what? The W. The W is equal to what? The U. So we now have from here, 1 over 3, open your brackets. Then we have what? Minus this, then plus. Integral of this function will give us what? The function over minus 1. Okay? You have to divide that function, your answer, by what? Derivative of what? Of the power. Plus what? Plus C. So we can begin to return the U back. Final conclusion, we're having, and that's finished what? Solution to the what? To the question. Question 6, we have find integral of this fraction. There's no direct table in this place. And when you spot something like this, best thing is to what? Use your what? Use substitution for the radical. So I'm going to say now, let what? For the solution, U be this. So with that now, I can, the best way, square both sides. So you have U squared equal to what? 4x plus 1. Okay? And that will be U squared minus 1 over 4 equal to this. Which we can make as what? 1 over 4 U squared minus 1. So we have what? Gotten an expression for x. Then the next thing to do now, we can differentiate this, the x with respect to U. So the x, make it and solve it, and we have this. Then begin to substitute to the given problem, or what you have gotten now, substitute to the given problem. So we now have 1 over, we have value for this as this one, okay? Then inside this one, we have a value for that, which is what? Which is U, and then times dx, there's a value for that, is equal to this, okay? So this one and this one we cancel. This one over 4. There's 1 here also. The inverse of 1 over 4 is 4. So I'm having 4 times what? 4 times 1 over 2. That's 2. So we now have 2 integral of 1 over U squared minus 1 du. And this is equal to what? This one is the difference of 2 squared. That's U minus 1 into bracket what? U plus 1. Du. And you now have 2 products of linear factor at the denominator, and also the degree of the numerator is less to what? To the denominator. That calls for what? Partial fraction. We now have this will equal to this one, a times this, that's a, and then over the product of the 2 products. That's the common factor. So we have expressed the right hand side as a single fraction. So the denominator in this place cancel. This place also cancel. So we can equate the numerator together. So we're having 1 equal to what? So the next thing to do now is to begin to substitute. So that certain expression will cancel. Let U be equal to minus 1. If U is minus 1, this expression will cancel. We can get this place. And that will be equal to what? 1 equal to what? Minus 1 minus 1. That's minus 2b. So b is equal to what? Minus 1 over 2. So that's my b. So also let U be 1. If U is 1, this expression for b will cancel, then we can get a. And that will be 1 equal to what? 2a. So a is what? 1 over 2. So we've gotten all the constant, we've gotten a, we've gotten b. So therefore we can go back to where we stop, and that will be equal to 2 times, my a is what? My a is 1 over 2, all over U minus 1, plus, my b is what? My b is a minus half, over what? U plus 1, okay? And don't forget your integral. On the final conclusion, this half can go outside, so 2 times half, that becomes 1. So I'm having integral of what? 1 over U minus 1, that's what? ln U minus 1, okay? Then this one also can also go outside times this 2, that become minus 1. So minus ln u plus 1. Then plus what? The constant of integration. So the next thing to do now is to return the u back. Okay, we have an expression for u, which is what? Which is this expression. Okay? So we can, before we substitute the u back, we can use the logarithm rules, and that will be equal to ln u minus 1 over u plus 1 plus what? Plus c. Okay? And then on the final conclusion, we have ln u is what? Square root 4x plus 1 minus 1 all over this. So, and that's end the solution to the question. Okay, at this point I want to say if you're new on the channel, smash the watermark on the video and subscribe. Okay, don't stop there, click on like button and begin to make the section interactive. Begin to make your comments, send your comment, type your comments, say something.